So we got a sequence going from 0 to 10 with the step amount of 1. And that looks like that in our watch menu. 0 to 9, 0 to 9. Clear so far, you have not forgotten anything. So here in this list, you can see the different functions you can do. So the first one says add item to the end or add item to the front. So what it means is, let's just take a look here. I'm going to delete these so we can just make them together. Okay. All right. So we say add item to the end. This guy will show up. So we'll just plug our list to it. Sorry, we'll just kind of plug our list to it. And then the item we're going to add in could be any number. I figured out that in the code block, you can just input your number. So let's say 999. Then you can plug this in. And if we have another watch window, we can see the result. So right now, we have a list that at the end, we have added this new item, 999. You could also do this for the add to the front, which would be the first of your list. So same thing, your list, your item, you will show up at first. The other interesting ones that you might want to use is chop, which will let you cut your list into smaller portions. So again, your list, you define your length, it could be 5, and you would just put that in. And now you see you're going to have 2 setup lists, and the first one has 5, the second one has 5. After that, flatten. Are you guys familiar with what flatten is? So usually in Grasshopper, when something doesn't work, you try to flatten everything. So that's how people started using it. Yeah. No, but seriously, when you have a tree of data, it defines, as I was saying, so you have the first branches, whatever it is, and then you have on the next layer the other branches under them. When you flatten, it will read the whole thing in one row. So when we did this grid here on the screen, let's find the marker. So when we did the grid here on the screen, let's say we have a 3 by 3 grid here. So we might have a tree of a list that tree looks like this. So we have 0, 1, and 2. Value, which each of them refers to each guy. And then each of these sublists have 0, 1, and 2. So that's 0 for this, that's 1 for that, that's 2 for this, same thing will happen. And the list will look like my 0 has 0, 1, and 2, my 1 has 0, 1, and 2, my 2 has 0, 1, and 2. But if you do a flatten, it will look like 0, 1, 2, 3, 4, 5, 6, 7, 8, and 1. So that's the difference. So this one has different layers, and you can call numbers out differently. And this one is all in one line or one surface. And that's that. So now let's say okay, so right here we have flatten. We just click on it, it's right here. You see our list here, the one that we did with the chop has two different sections, and each of them has 5 different elements in it. We just add this to, and then it will ask the amount of flatness you want to do. You want to do 1 layer, or you want to do 2 or more. It depends on how many layers and sub-lists you have within your list. And it will look like that. It will look like this. So it has flattened my list to an amount of 1, and now I've got everything in one row. When I'm done defining these with the numbers, I'm I'm going to show them what they mean in the grid. So that's going to be a little bit more maybe clear and more fun a little bit. So that was flattened. We have also join, which you can just again click here. You say how many lists you have, and you just plug them in. You will get a joined list again from all of those. We have max and min. So right here, you can say, hey, here's my list. I will input this, and I will have a bunch right there. What is my max element? It will show us the value of maximum element on the list. After that, we have shuffle, which might be interesting at some point. It's a little bit random. I mean, it is random, but it is useful all the time. So again, your list, it will shuffle it for you like that, and will give you a result. Now you see all the values here are shuffled. Slice, kind of similar to chop, but this time you're gonna have a start, an end, and how many steps you're gonna do. So this is almost the most interesting one in Dynamo, and it's different from what we had in Grasshopper. So if you have a list slice, you say start at 0. Let's say end at 6, and don't do anything for the steps. So it will show you from 0 to 6, 0 to 5 actually, so 6 steps. And then if you say now step it, I don't know, with a number of let's say 2, now you see every other item in the list. You can step it by 3 and 4 and whatever you want. So in a grid or in a line of points. Yeah. So whenever you have a set of data, it will come up as a list. Then you want to do something to those data that you have. You want to pick one of them, or select a group of them, or do something to them. So let's say the very common example of circles. So let's say you have a grid. And you want to somehow say, hey, select some of these and make a circle for me, and that would be my, these would be my windows in Microsoft. So you should have a way to say, hey, Dynamo, this is the list of the points I want to put a circle on. What you have is something looking like that. You need to find a way to add lists better. So that's why knowing how to work with the list is very important. It's kind of boring, but it's almost all the time the most problematic and most important part of in programming. What's that? Okay, so slice, I think you got it. Also, we have transpose, which I will show in a 2D grid later, which is basically if you call out stuff, it will be like 1, 2, 3, and 4. And if you do a transpose, it will be like 1, 2, 3, and 4. So that's kind of rotating how you call out numbers in a matrix. And then get item at index. So if I find here, right there, this is very simple and probably very useful as well. So you just put in a list and say, hey, I want to see item 4, for example. You will plug this in, and you will attach that to your watch. And now you will see your item 4. So this happened that the value is 4 too, but I'm looking for the index right now. So that was the list just using numbers. So right now let's go and do kind of those stuff in the grid and using those circle examples. So what we did before was to show how we can draw circles around our points using an attractor point, and kind of similar to this. Now I'm going to just turn off the attractor point, just do simple circles around the points with the radius of 20. 5. Okay, so now all my points have a circle around them with the radius of 0.5. What I'm gonna do right now is to show you guys a few of the list functions that I just showed you in this matrix. So first of all, let's do let's say oh no, let's do slides. I'm gonna do slides. It will give me that. I will go to my list of points. And it's always good to know what you're dealing with. So always have watch or panels in your programming environment where it show up here. Okay, so here you see all these numbers, all these points that I'm working with. So I'm gonna say give me so now I've got a series of, and I'm not sure if it's clear there or not, but a series of my points here are blue, starting from the, the, the third row, which is 0, 1, and 2, and going to 6. So these are the 4 rows that I have selected in this slice function, and I can just say draw the circles around those ones here. So that's a way of calling those circles. Any questions so far? Aside from the stuff that might be confusing on the list? No? All good? Okay. So that's that. That was very simple and easy. The other one is to get item from a list. So let's take that guy over here. Remember I said it will get very messy very soon, so that's kind of what's happening right now. So you have a list here, you say index 4, you drag it in, and then you make a circle around that. So again, you see in the row 4, you will get all the circles around it. The reason you say one item and it shows you a row is because of the tree structure of the list. So what the way it reads is you have one line over here which has items 0, 1, 2, 3, and 4. The second line has 0, 1, 2, 3, and 4. And then you say give me index 4, it will give you all the folds and all those different categories, whatever they are. And then you can also flatten your list to get all of them in one surface, like that. Then call out your item 4, and now item 4 is a different one. Just to show you what that means, I'm gonna put a slider there. Slider. Now I can call out each of the points I have in my matrix one by one and go through them. So these are so what again, so what I said, you need to address and say I want to work with that point or this point, and these are different ways of addressing. More complicated than that is that if you want to say I want to work with every other point, or the points that are closer to this line, or the points that are further from whatever number to this I don't know points that I'm measuring from. So again, for those you can define conditional functions, and then you can define similar to Grasshopper. We have an item that we could define a pattern of trues and falses, and then the ones that are false will remain in the list. The trues will remain in the list. The ones that are false will be deleted from the list, and then you will collect the ones that you want. I think we can show that more details next probably, but it's very simple. In the code, you can say if A was larger than 4, give me true, and then you will define a line, measure the distance, say if the distance is more than 4, keep it. If it's shorter, delete it. It's a bit more time consuming. I'm going to show that in detail for you guys next session, hopefully. And then transpose, I'm going to show that as the last item here in the grid. Okay, so we have this slide. Let's get that back in. I'm going to delete the flatten. I'm going to delete the that's 0. Okay, so we have this, and that was my rest. And then what transpose does is no, I'm not gonna say that. Yeah. Yeah, so always is that you have something out there, you kind of know it is there, and you want to say, hey, this one, but there's no place to say, hey, this one. You have to find a way to select that. Or even more complicated, let's say you have a set of, the same way the attractive points work. So you have a set of distances measured from points, and you were lucky enough because they were in the same order as your points are. And then when you assign the circles to each of those distances, the right dimension of the circle will align to the right point. But if the left brush was shifted a little bit or were shuffled in a way, you would end up with having just the random results, which you have to come up with a way to solve that. So a lot of the time you'll end up having all these lists of information. You're trying to find a way to connect those and align those, and that would be kind of difficult to do. So again, back here, the transpose is basically just rotating the way you add the matrix. So before you were saying these are the first 0, 1, and 2, then these are the secondary ones. And if you do the transpose, the positions change, and then these are 0s, 1, and 2, then these are the secondary ones. That's what it does basically. Yeah, and as I said, it's almost like a language you want to talk. So again, you'll see things and you want to show them, hey, that one. But to say that one, you need to know the language to add it. So I think the next step, I'm going to show how to create. Sure, yeah, that's good. Both of you. Okay. Click. Delete. You mean like tag them on the geometry? I don't know how, but I'm sure there is. Oh yeah, yeah. So if we open your Dynamo through Revit, you can use functions. I think we can show that next session too. Functions such as select face, and then similar way in Grasshopper, you would just say, I'm going to select face. It will show you the Revit. You just click on the face. It will be selected as your face. So you can also do the same thing in families. So you can pick a family, select the family type. You can move your families around, or you can change the. Let's say you have a door, and you can define the breadth of the door as a variable here in Dynamo and change that to Dynamo, and that will show up in Revit. So you can do all that kind of stuff. And it's not that difficult at all. Okay, so next step is, any more questions? Was that all? I'm just showing all these areas. No? Good. Okay. So next step, I'm going to show you a few techniques of drawing surfaces um, in, um, in Dynamo, and I think Stephen after that is going to show you how to panelize them and how to approach kind of the similar thing that he was showing last session, from starting from scratch and thinking of it not as a design solution and understanding it, but as a way of designing that. But to go there, how do you think we can define a surface here in Dynamo? If you wanted to make a surface, like curvature, something, how will you draw that? Something. Okay. Yeah, but I mean, in a way of strategy, how would you start and how would you end your real program? Yeah, kind of. Yeah. Any other way? Yeah. Yeah. Okay. So yeah, so exactly the same idea. So if it's a flat surface, you could say maybe a few points and then find a way to connect them, and maybe kind of define that as a surface. If it was a curve, you could define a few points, draw a curve on that. You could offset it and create a lock, or you could do your points and one curvature. You could do another curvature and sweep it and go it around. So I'm going to do one example of just creating a surface and then pass it to Stephen to take it from there. I'm going to delete everything from here, and please let me know if there's any questions that are inside. Okay, I'm going to start with the point, y coordinates. I'm going to put it here. Stephen told me that you can just move these. Not you can. Okay, yeah, so you can just move them here around, and it will give you your sliders like that. And I'm going to have a second point there and a third point. And each of them is in a different. Okay, now I've made my 3 points. Um, Here I'm going to define a curve. So here in the library, let's go to geometry, and on the curve you see all different types of how you can make a curve. Over a line, over the poly curve. So we do have poly by point. That's our poly. We put in all the points. Okay. I should define a group of points. Okay. Uh, that's what I showed you. Okay, so you create a left, like that. I was expecting to select shift or something as a, so it will make that for you. That's the curve. You could also do different type of poly. But let's say we're going to do that for now. And then you can have, you can even offset this the same way we said, or you can draw a new set of points and define curve. So here's offset, you do curve, you define your distance. It has something by default, which is 1. I'm gonna give it 4 or something. You'll make the second curve, and then you can do log. So here, if you go under polycurve, there's a polycurve by tone, where you can do that. One more thing, the way Stephen did it was to drawing 3-point curves, which you could also do and get arches instead of the lines. You can try that too. So first point, second point, and third point. Now you have arch. I'm going to copy and paste this there. And I'm going to this time give them a little bit of z coordinates. So let's say 35. That's going to be z for all these points. Or even just for 2 of them. Then you can, so here's the geometry, like that. I think the best way to do right now is to sweep it. I want profile, I want path. Okay, it doesn't work. Let's do it simpler. I'm gonna do it like this. Now simple. Now loft should work. So you have different types of sweeps and lofts that defining based on what topology you have. You might want to use those. There you go. Right. So any questions here? So after you have made your surface, one way to approach it is the same way we have the grid on the flat plane. You can define the UVs on it, and each of those points will be placed somewhere on the curve, and then you can again call those out and put a, I don't know, sphere on it and zoom in or do anything you want based on the idea you have behind your